This problem is starting us off with the first derivative equation. So they're telling us our first derivative is equal to this equation right here. They're telling us the interval that they care about. So we only care about what's happening between 0 and 2. And they want to know on what intervals there is our original graph decreasing. So notice that they want to know when is our f graph decreasing. Whenever you're reading the derivative equation, the derivative is always telling you the slope of the graph. So what we know is wherever our derivative is positive, that's where our graph would be headed up and increasing. Whenever our derivative has a negative value, that's where our graph has a negative slope and is therefore decreasing. Wherever our graph equals 0, that's where it kind of had a horizontal tangent line. And that doesn't mean that it changed from increasing to decreasing. It can. That's when we see maxes and mins. But the graph could also have just gone sideways for a second. So it could have just kept increasing or just kept decreasing. When you first see this problem, you're probably saying to yourself, oh man, I'm going to have to set this thing equal to 0. I'm going to have to do all these number lines. Remember that this is a calculator required section and that you just need to be able to read a graph off of this in order to determine whether this original function is increasing or decreasing. So we're not actually going to have to do a whole bunch of work by hand. We're going to do it all in the calculator. So when you look at the graph of a derivative, when you're reading that off, wherever that derivative graph is up in the positive space here, that's where our original graph was increasing. Wherever our graph was in the negative space down here, that's where our original graph is decreasing. And then wherever it hits that axis, that's our 0. That's where it went horizontal. Those are our critical values. That's where this graph could have changed direction. So what we're going to do is we're going to graph this thing and find out what's happening. What I'll do is I'm going to start off by graphing that derivative function. So I'm going to go in, I'm going to write the directions down now, and then I'm going to show you exactly how to do it on the calculator here as soon as we get through it. So step 1 of the process, I'm going to go into y1, and I'm going to put that derivative equation. So sine of x cubed minus x. In y2, I'm going to put 0. That's these critical values here. Those are going to be the places where this graph has the potential to change direction for me. And so what I want to do is find out where those places are and be able to calculate them real quick and easy. From there, I then go ahead and graph this equation. I might adjust my window here. I think I probably will on this one because they give us a specific interval. Sometimes they don't give you an interval. You won't have to adjust the window, but here they do. I'm going to graph those two equations then, and then the thing I'm going to do is I'm going to read off the graph, and what I'm looking for off the graph is I'm looking in this situation, I want to know when is this graph decreasing. And so I'm looking for wherever this graph is down below here, wherever it's in the negative. I want to be reading off wherever my graph is down below here. And then what I'll do is I will find where those points are where it changes by finding the intersects of my two graphs. So I'm going to do a second calc, and then inside that calc menu, I'll choose the number 5 option, which is intersect. From there, our calculator is going to ask us a few questions. We'll answer them, and we'll get out our answer pretty quick. So I open up my calculator. I'm going to go to my y equals. That's the button in the top left. Everything in your AP Calc test is always going to be in radian mode, so make sure your calculator is set to radian mode. So you would hit mode and then check and make sure you're in radians whenever you're doing trig work. I go to my y equals then, top left corner, and then I type in that equation, exactly how it looks. So sine x to the third minus x, and then 0 in y2. And like I said, not always will you need to adjust your window, but on this one, they gave us a specific interval here, right? They wanted to know what's happening specifically from x from 0 to 2. So I don't care about everywhere. I just care about an x min of 0 and an x max of 2. And because all I care about is where this, where it changes, where it hits these critical values here, I'm also going to squeeze down my y min and max just to make the graph a little bit easier to read. So I'm going to go -1 to 1. This type of adjustment you just got to get comfortable with as you go into the test. Then from there, I'm going to hit the graph button in the top right. And I'm looking now at the graph of my derivative. So what I can see is, in this situation, I'm worried about where it's negative, right? We wanted to know where it's decreasing, so we're looking for where it's down below that x-axis. And what you'll see here is you can see that this graph is down below the x-axis, starting over here on the left, and then ending right here in the middle someplace. So that's a decreasing section there. Then the graph goes into the positive space, and then here again hits 0 and drops down into the negative. So that's another decreasing section. So I know I have two decreasing sections, and now I just need to find what those actual points are where it's changing. So I want to find the intersect between these two graphs. I'm going to hit Second, Calc, and then from there I'm going to choose that number 5 option in that menu. So the Calc button is the button above Trace at the very top. I hit enter on intersect. The calculator then asks me a series of 3 questions at the bottom here. The first 2 questions you could always really care less about. It's going to say, is that the first curve? Yep, that's the first curve. Go ahead and hit enter. It'll switch automatically to the second curve for you and say, is that the second curve? Yep, that's the second curve. So go ahead and hit enter. And then from there, it's going to ask you to guess. You can actually type in a number right now, or you can just scroll your cursor. So I want to guess over here towards 0. But I could also just type in 0. The guess is really telling the calculator where to look. You're not influencing what the outcome would be. So I think it's happening at 0. So I type in 0, and you'll know you did everything properly because it will say the word intersection at the bottom of the screen, and the x value you're looking at is going to be the start of your interval. So right now, looking at my interval, I know that I've got an interval starting here at 0. And now I need to find that middle intersect. So I just start the process over again. I hit the second button, choose that Calc menu, the button above Trace at the very top, and then again choose that number 5 option, intersect. First curve, yep, just hit enter. Second curve, yep, just hit enter. And then just start scrolling your cursor. And kind of once you're past the halfway point, it's always going to find the one it's closest to. You just kind of hit enter again. And now we're looking at 1 for that. So I know that we began at 0 and ended at 1 for this first segment that's in the negative space right here. Now I need to go calculate out this second segment. So I just start the process again. Second, Calc, number 5, intersect. First curve, hit enter, yep. Second curve, hit enter, yep. And then from there, I go ahead and scroll my way all the way over here to the right, and I hit enter on that part because that's my guess. And it tells me 1.69. AP Calc tests always round to 3 decimals on their answers, so that's going to be 1.69, and that 6 right there behind the 0 will round that up to a 1. So 1.691. Then as I look for the end of this interval, even though this doesn't actually go back up and hit our graph right there, because our interval is set to end at 2, that means that it stops as far as this answer is concerned at 2, because we don't know anything more than that and they don't care anything more than that. So in this little world from 0 to 2, it's decreasing all the way up until the end of that window at 2. And then this is interval notation is what I've got it written in, but when you go to write it on an answer, that would look from 0 to 1. When it's brackets, that includes, so that has the equals. And then here we'd be doing 1.691 is less than or equal to x is less than or equal to 2. So those are our 2 intervals where this graph was decreasing. And so our answer in this situation would be option C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.